Okay, the problem statement is that we have come to a store to steal some things, and we have a backpack or a knapsack, and the capacity of the knapsack is 10. So if you carry more weight than 10, then the bag will rip apart. Now there are 4 items in the shop, and these are the indexes of the items, and the second row is the price of the items, and the third row is the weights of those items. Now we have to find out that what is the most price that we can carry without ripping the bag apart. Now we are studying dynamic programming, but first we will just find a solution of this problem, and then we will see how slowly we can turn that into dynamic programming. For now, we will just go for a solution. So the question is, you have entered into a shop and you have 4 objects to steal from, and the capacity of your bag is 10. What is the maximum that you can steal? So we will phrase our questions into 2 parameters. Number 1, from which object will we start considering right now? And number 2, how much capacity of the bag is remaining. So as you can see, there are 4 items and they are indexed from 0 to 3. So we will go one by one to the item. At first we will consider the item that is at index 0, and then 1, and then 2, and then 3. What I mean is that we will consider every possible scenario of the whole situation. So there can be different combinations of stealing, right? So you can take the first object and then not steal the second one, and then steal the third one and not steal the fourth one. Or maybe not the first one, the second one, and not the third one and the fourth one. There are so many combinations, right? So we will consider all those combinations, and starting from the first item we will consider both choices. We will take it or we will not, and we will see ultimately that which choice makes us a better choice in terms of pricing. So let's say we will have actually 2 properties. The properties will be that the index we are considering right now. So I am just gonna name it index considering, and the second parameter is going to be capacity left, that is how much capacity is left in the bag. So we start considering from the first index, which is 0, and the capacity left at this point is 10 because we haven't considered taking anything in the bag. But right now we are considering the first item, that is 0. So as you can see, now we have 2 choices. We can take this item and we can leave this item, and we have to consider both cases to reach to the solution, and then ultimately we will consider all the cases and then find the maximum one. So let's say from this moment we will have 2 branches. The left branch will always consider the item that we will be taking, and the right branch will always consider that the item will not be taken. So the first item is at index 0. Right now we are thinking here, and let's say the left branch will be that we take this item. So let's say the left branch means we will actually take this item, and if we take this item then we actually get some price for it, right? We can sell it later and get 7 units of money. And when you take an item, you have finished considering this item, so you will never consider this item again. So the index will increase by 1 because next we will be considering the item which is at index 1, and as you have taken this item in your bag, the capacity of your bag will be a little less. So the weight of the item at index 0 is 3, and your bag had capacity left 10, but now that you have taken an object which weighs 3 units, so now the capacity of your bag will be 7. And this is the branch that we're considering we have taken the item. And there will also be another branch which we will consider that we have not taken the item, and let's say we denote it by not taken, and we can denote it by taken. Okay. And in this case you have also considered the first item because you have decided not to take it, so you will not consider it again. So the index also increases, but the capacity remains the same because we have not taken the item, and as we have not taken any item, no price gets added. Because in the left branch we have considering that the item is taken, so that's why we have to add 7 because the price of the item at index 0 is 7. But on the right branch we are thinking that no, we are not taking this item, so 0 will be added. Now this will continue because we will ask the same question at every point. So right now we are at this point where we are considering the index 1 and we have 7 left in our bag. And right now we are considering the item at index 1. So it will also have two branches. The left branch will be taken and the right branch will be not taken. Let's say we are not writing it right now. If anything blank, it does mean that it's not taken. So if we take the item at index 1, then we have considered it, so the index will increase to 2, but the weight of the item at index 1 is 5, and from 7 if we subtract 5, then the capacity left in our bag is right now 2, and the price of the item is 10, so we have to add 10 here. And if we consider that we are not taking it, the right branch, then the index will obviously increase because we have considered this item and decided not to take it, but the capacity will not change because we haven't taken this item, and the price will be added, that is 0, because we haven't taken it. Similarly, on the right side, the situation 110, if we take the item from this step, then 10 will be added because the price of the item at index 1 is 10, and the index will be 2 because the index has been considered, and as the capacity was 10 before this decision and the weight of this item is 5, then it will get reduced to 5. But if we don't take it, then the index will be increased, but the capacity will remain the same and nothing will get added. Similarly, if we continue again from the position 2, 2, then we are considering the item that is at index 2 and the capacity left in the bag is 2. Now we will face a special case. As you can see, the weight of the item at index 2 is 5, but the capacity left in your bag is 2. So even if you want, you cannot take this item, because if you take this item, then your bag will rip apart and everything will fall and you will get caught. So even if you want, we cannot consider the left branch here because we cannot take the item. So the only branch left is the right one. So we'll go to the right one and we cannot take this item. So the price added will be 0. Now from 2, 7, we can take the item at index 2 because the leftover capacity is 7 and the weight of the item is 5. So if you take this item, then let's say it's taken and the price will be added is 10 because the price of the item at index 2 is 10, and the index will increase to 3 and the capacity will reduce to 2 because the capacity was 7 and the item that we have taken weighs 5, so it will be returned to 2. And from 2, 5, if we, before that a little bit, there was an branch, that means that we cannot take this item, so we will increase the index but we will not change the capacity. Yes, the figure is getting a little bit congested, but I hope you can understand. And from 2 5 the left branch will be this, and let's say the right branch will be this, and the left branch means taken. We can take the item here because the leftover capacity is 5 and the weight of the item is 5, so we can add 10 here, increase the index, and the leftover capacity is now 0. That means the bag is full. And if we don't take the item, then the index will increase but the capacity will remain the same. Similarly, from 210, if we take the item here, 10 will be added, the index will be increased to 3, capacity will drop to 5, and if we don't take it, then nothing will be added and index will be 3 and capacity will remain the same. And for the last phase, now we are considering the last item, and as you can see from the 3 2 we cannot take the item because it weighs more than the capacity, so the only option we have is not taking it, and we can go to index 4 and the leftover capacity is 2. Here the same case will happen because it's also the same situation, so we cannot take it. From 3 7 we can actually take the item because the capacity left is 7 and the weight left is 7, so it will go to 4 0, and the price of the item, that is 12, will be added, and there will be another branch where we won't take the item and it will go to 4 7. From 3 0, even if we want, we cannot take the item because the capacity exceeds, so it will go to 4 0. From 3 5 we also cannot take the item, so it will go to 4 5. From 3 5 here we also, the same situation, we cannot take it, so it will go to 4 5. But from 3 10 we can take the item because it weighs 7 and the leftover capacity is 10, and 12 will be added, it will be 4, and 10 minus 7 is 3, and if we don't take it, then it will go to 410. And that's all the cases. Now the tree has gone to some point where the index is 4 and there is no index 4, so no item is left to be considered, and at this point the whole tree is built and every possible scenario is on this tree. So let's say you want to find out a scenario which indicates that you have taken this one, haven't taken this one, have taken this one, and haven't taken this one. Then it will follow, as you see, the first item is taken, so you will follow through this way, and then you haven't taken the second item, so you will go this way. Right now we are here, and then you have taken the third item, so you will go this way, and you haven't taken the fourth item, so you will go this way. So this path denoted by the green lines is the case, that is, you have taken the first and the third item but not the second and the fourth item. And as you can see, if you follow the prices along the arrows, then it's 7 and then 0 because you haven't taken the second item, and then 10 because you have taken the third item, and then 0 again. So the total cost goes to 17, which is true if you take the first and the third item. So now if we traverse all these paths and calculate the profit that we will get in each path, then if we consider every path, we can find out the maximum we can get. So I will quickly calculate the cost of each path and see that which node calculates which price. So this node will get 17. You can also do it on your own and you can also find it out. I don't think it's very hard. You just have to add the prices along the edges, and this goes to 19, this one goes to 7, this one goes to 20, which will be the maximum ultimately. This goes to 10, this also goes to 10, this goes to 12, and this goes to 0. So now we can see that the maximum is 20 here, and if we traverse the path, how we can get there? We can see that we will get here in this way. The first item not taken, so we don't take the first item. The second item taken, so we do take the second item. The third item we take, so we do take the third item, and the fourth item not taken, so we don't take the fourth item. So that's how you get to the maximum value 20, and you can see that it considers taking the second and the third item, and that is indeed the answer. So if we can calculate each of these possibilities and then find out the maximum one, we will get to the answer. But yes, this is not dynamic programming. This is just simple brute force checking by checking all the paths we can go. But in the next video, we will actually see that how dynamic programming can also solve this problem and also reduce the complexity of this problem.